Okay, let's do two more examples about the graph of trigonometric functions with amplitude, uh, period change and phase shift, or maybe with a stretch. Okay, so I was asked about the problems on page 582 from problem 17 to 40. So I'm going to pick up two of them to do the practice. So before we sketch the graph, we have to clearly know the basic graph. For example, if you want to sketch the graph involving secant, what is the basic graph? The basic for the secant is like this. First, you sketch the graph of cosine, and then you flip it. The red curve is a graph of a secant. Okay, and if you have a sine function, you flip it, then the red curve is a cosecant. Okay, if you have a tangent, the tangent looks like this. Tangent, it's one period, and then you just repeat it. This is pi over 2, negative pi over 2. Here's pi over 2, 3 pi over 2. Here's a pi and 2 pi. And the cotangent, cotangent you'll have this way. This is pi over 2, 3 pi over 2. It's a pi, 2 pi. So y equal to tangent of x. Y equal to cotangent of x. So first, you have to have those basic graph in mind. Now let's try to sketch the, for example, 31. 31, we want to know the graph of y equal to negative 2 cosecant of pi x. Okay, then let's try it. For the cosecant, I didn't label. So y is cosecant of x. You also have 5 special points, key points. And you let pi x be 0. When pi x be 0, x is 0. X is 0, it's vertical asymptote. Pi x be pi over 2, this is pi over 2. X is 1/2, then this is 1. Y is equal to 1. Y is equal to 1 times negative 2. It's negative 2, okay? And the pi x is equal to pi, well, x is 1, it's a vertical asymptote. When pi x is equal to 3 pi over 2, the x is 3/2, you have this negative 1. So y is equal to negative 2 times negative 1 is positive 2. When pi x is equal to 2 pi, at this point, x is equal to 2, you have vertical asymptote. Okay, now let's try to sketch it. 0, half, 1, 3/2, 2. So we have 0, 1, 2, half, half, 1, 3/2, 2. At 0 is vertical asymptote. At 1 is vertical asymptote. At 2 is vertical asymptote. At 1/2 it's negative 2. For example, assume this is negative 2. Check here, it's negative, so you have to flip it. So the graph looks like this. And when you have 3 halves, y is equal to 2. Flip it up. So use a key point. Use a key point, you can quickly sketch the graph. Okay, this is a problem 31. But to get this problem, to get the sketch, you have to keep the standard picture, standard graph in mind. This is a cosecant. Let's do another example. Let's say cotangent x minus 1, 34. Y is equal to 2. Let's change it. For example, not 34, 33. Okay, let's do 33. Y is equal to tangent 1 over 4x plus 1. Okay, so tangent, how many special points you have? You have a 0, negative half 2, positive half 2, and if you want, you can also add a negative half of 4 and a positive half of 4. Because again, I used to mention tangent negative half of 4 is negative 1, tangent positive half of 4 is positive 1. Other angles, even though you know the value, they are irrational. You cannot label them clearly. Okay? So you have 5 special, the origin, 5 special points. You let 1 over 4x equal to negative pi over 2. 1 over 4x is equal to negative pi over 4. 1 over 4x is equal to 0. 1 over 4x is equal to pi over 4. 1 over 4x is equal to pi over 2. Then you get the corresponding x value. So here x is what? It's a negative 2 pi. Here x is a negative pi and 0 and pi 2 pi. And y here for this one is a vertical asymptote. It's a vertical asymptote. And here is a so tangent negative half of 4 is negative 1 plus 1 is 0. Y is equal to 0. And 0, tangent 0 is 0 plus 1 is 1. Tangent this is y is equal to 2. And here's the vertical asymptote. Okay, so let's try to sketch it. At negative pi, 2 pi, negative pi, 0 pi, 2 pi, so pi, 2 pi, negative pi, negative 2 pi. Here you have vertical asymptote, vertical asymptote. At 0 you get 1, y is 1, so assume 1 is here. At negative pi you get 0, so negative pi you have 0. Positive pi you have 2. 1, this is 2. So if I sketch it, it will be like this. See? Because the graph, the standard graph is like this. So you just follow its trend to sketch it. Okay? So this is the second example. Anyway, all the problems can be solved by this. You determine the key point. So let's try it. The key point for the tangent, negative pi over 2, negative pi over 4, 0, pi over 4, pi over 2. The key point for cotangent, 0, pi over 0, pi over 4, pi over 2, 3 pi over 4, and pi. 5 key point. Secant, cosecant is 0 pi over 2 pi, 3 pi over 2. This is 3 pi over 2 and 2 pi. Secant, this is cosecant. Secant, you can put a negative pi over 2, 0 pi over 2, 3 pi over 2. No, not 3. This is pi. I always consider this is a 3 pi. This is a pi, and here 3 pi over 2. Yes, now I'm right. Okay, so 5 special point. And then you have to get the right the right graph, basic graph. Okay, so okay, that's the example about those graphs.